Hi everyone, my name is Natalie Serebryakova. I work as a staff cloud engineer, and today we're going to talk I'm going to talk about ways to save your cost when you work in the cloud, and specifically when you're planning on your disaster recovery. Disaster recovery is the chosen exercise, so basically anytime when you're planning on building a product or delivering certain projects in the cloud, I would recommend not just thinking about architecture, about resources, but also do like a little bit of the calculation of what you're going to deliver. And I will cover that during this talk. And one small note as well, during my work, I primarily work with AWS. So a lot of examples through this presentation are from AWS Cloud, but generically, all the cloud providers have similar solution or the same solutions for things we are building. So this should not affect anything. So as I said, my name is Natalie. I work as a cloud engineer, DevOps or infrastructure, SRE, whatever you prefer. I worked at different companies. Also, I do some consulting around DR procedures, around compliances and the cost. I'm also a AWS community builder. If you ever in Bay Area, California, United States, and you like to speak at the meetups, just ping me. That's my LinkedIn. It's real ID and URL. And yep, let's start. So agenda for today, as I mentioned, it's disaster recovery, understanding the cost, talking about real exercises in terms of if anyone wants to understand how to start calculating the cost of your projects, where would you start, how would you approach certain things, and I would like you to learn how simple it is with estimation of everything we are delivering and architecting. So, does anyone here was part of like disaster processes or recoveries or incidents during their career? Oh, that's nice. That's good. So, what are the disasters? I just want to make sure that the material and slides are relevant. So, if something I see that everyone familiar with, I will just skip through, since I don't want to hold us from the next activity. So different disaster types, right? Sometimes those are more like natural disasters, data center fires, earthquakes, sometimes power failures, things like that. In some cases, we can call disaster activities like someone deleted certain resources, like databases or could be EKS clusters. It could be mistake. It could be specific access was provided incorrectly. So all these kind of things during this presentation I'm going to consider as a disaster. And sometimes when I have to speak to certain companies or customers, I need to clarify that high availability, that what we've been told through documentations and cloud best practices are not the disaster recovery. So whatever we have high availability, it's great. That's how we should build our applications, but it doesn't mean in any way that we are protected from disaster that might occur, because when we're thinking about disaster recovery, we have to think about most likely migrating not just between AZs with a cloud provider, but mostly to different regions or even different data centers, or in different data centers outside of the cloud. Your disaster recovery process could look like that as well. And then when we're designing disaster recovery, there are certain things that we need to provide. There are some procedures that we need to go through, but the idea, if you never was part of the process, or let's say you haven't designed processes like that, is the time. So on this slide, you can see that there is a lot of focus on the workload, and workload, it's not only the single applications or or set of applications, is mostly the performance of the product that is currently used by the customers. And for disaster recovery, the very important part of this whole slide is that measures help us to understand how quickly it takes for us to get to the state where all customers are happy and product functions well. So there is something to consider. And I will explain why on the different slide. So when we are designing disaster recovery, we usually, as I said, talking about time. And there is another thing that comes with that is the resiliency. So there are different resiliency objectives, which sounds very high level and very abstract, but if we think about the applications, about infrastructure, about the resources, it comes to the certain things that the most measurable and crucial thing for us is most of the times RTOs and RPOs. And I don't want to throw like fancy abbreviations during this presentation. So recovery time and recovery point, those things have to be like starting points when you're designing any disasters. So on this slide, again, if you never heard these terms, I'm just trying to explain what does it mean. So for, let's say, disaster happened, and in some cases, for some disaster recovery processes, people have backups, but those backups might be like taken not every minute, not continuously, but let's say every other hour. So when we're talking about designing the recovery, we need to calculate that even if we have this last backup hour ago, there's still hours of events that when we don't have this data, can we still function as a product? If, let's say, if everything went through, did we plan our disaster recovery? There are certain fulfillment mechanisms for us to fulfill that data, and how that that missing period of data will affect the performance. So that's why RPO and RTO are important when we're talking about the process, designing the process. And also, those are not abstract numbers. They actually, engineer and infrastructure history team, they need to understand. And that's like if you're going through, let's say, SOC compliance, which is very popular in the United States. I'm not familiar how enforced this kind of compliance here, but I'm sure there are other compliances that like you have that word written in your compliance that you are DR certified or you have a process, and your RPO and RTO take this much. And I recommend testing these numbers. It's pretty much possible. So resiliency is how quickly we can recover, but if you ask any infrastructure person, they will also tell you that it's how quickly you can acquire the resources in the cloud, because we know there are different cloud providers, and imagine if, hopefully never happens, region will go down, everyone will have their disaster recovery processes. And if you have specific instance type, which is used very often, right, you might face some issues acquiring those when you actually need them, because probably every other company from certain region will start doing the same. So you just need to think through this and, again, put it in the disaster recovery process. And yeah, another point I want to make, and I researched this, and this applies to any cloud provider. So we need to understand when people say, oh, I'm not in a prem anymore, I'm using cloud, that's why I'm safe. That's not correct. So cloud provider guarantees certain things for us, but there's many other things that could go wrong during disaster recovery. Same access we talked, networking, all the architectures we have. So when we say that we have specific resiliency when we're designing DR process, we need to calculate that. And this is very important part, which I don't think it's mentioned enough that people realize that. Okay, so disaster recovery is what? Combination of our strategies and the services we used to recover quickly from data loss and any downtime. Now, cost. I know there is a thought that a lot of things in the cloud are can be taken down, they can be experimental, and in the many teams I work, there is no actually visibility in terms of how much my company spends, what our AWS bill, but then we get tasked once in a while to understand why certain service or why certain bill went up all of a sudden, right? So it still comes on our shoulders as an engineers, and a lot of things we do, it's more like going through the console, understanding or checking what was in the commit that actually spiked that cost. So when we're thinking about disaster recovery, and that's what I'm trying to achieve with this presentation, we don't have to be reactive, but we can be more proactive. And once we're more proactive, we understand what is our spend, and then we can go to our architect and say, hey, this spend is maybe more or less that we could afford sometimes. Is there a way to make to work with us or make the solution we are building more resilient? So cloud estimation is the process we're trying to forecast the spend, and obviously optimization is when we optimizing resources, reviewing them, and this should be actually process of any company, at least on a quarterly basis, killing like unused resources, or let's say reviewing instances that we used, reviewing databases, optimizing them. And it's maybe sounds scary for people who never did this, but there's so many tools. There are third-party tools, but also your cloud provider already have this baked in, just not many people are aware of that. So why it's important, now I can tell you that there is something that sometimes, again, as an engineers, we maybe don't really pay attention to, but our organizations or company, their main goal is to make the revenue, and the benefit of building efficient cloud product and resources is to make sure your cloud spend goes in good hand, leg by leg, with your revenue. So sometimes when you overpay certain things, it can cost someone a job, or the product then will not make much sense when the revenue is just not generatable. So the business continuity planning, when the leadership does this kind of things, they always include things like spend on the cloud. That's why it's important, because disaster recovery process is a heavy process, probably the most heavy, I think, after the actual product that company should be building. Debatable, but I guess that's just because disaster recovery hopefully doesn't happen that often. That's why I think this debatable. Otherwise, it's probably the second thing that should be really architected well, and that's why it could be very costly. It could be, I have seen cases when it's like almost half of the bill that people pay to the cloud providers, just because of the certain things like design. So it's not the end of the world, but for leadership, it might just not make sense, just by doing basic math. So optimizing disaster recovery, if you ever use the cloud, there's so many resources, so everything can be optimized. In my opinion, the very important resources when you look through them is compute, it's our storage. Very cool one is license. When you discover, like, let's say, sometimes you run specific things. Happened to me when there was a specific machine for the data team that handles specific job, and it has that specific license that actually requesting that license takes months and months to get through. So disaster recovery is not possible. Like your RTO and RPO will be just very bad, and unlikely you will recover from this disaster recovery quickly. So the good thing to think through this, as well as the support. If you're on the right support, sometimes when the things go wrong, you can reach out to your cloud support engineers. Most likely it would cost extra, but thinking through that is good. At least you will have the contact number of the support person who is available during the disaster. And then tools. I said I will cover certain tools, and that's what I'm trying to emphasize with this presentation, that and I know when even I read through the documentation, it sounds like very abstract, but as I said, if you have a budget for your DR strategy, this is your budget. Then when you set basic alert, when your budget goes over that spend, that's what you need to know, and then that's like you at least preparing yourself and you reviewing your architecture, you're becoming a better engineer. Pricing calculators. AWS have a very cool tool, which is QuickSight. It's something similar to Tableau if you use Tableau. I think they're actually part of Google now. And all these things can be ported to those tools to show you things that you don't even have to calculate. Cost management tools, there's a lot of them. There's third party, they can be paid as well. And continuously review and optimizing is not that hard. Specifically, if you use infrastructure as a code, Terraform. Terraform is infrastructure as a code, but I feel like with Terraform you can do much more. You can add certain things that actually help you to review your resources and optimize them. So this is the slide for just simple example. Like I said, every cloud provider has their own pricing calculator. It's all there. They do have the API. So if you enjoy writing your own tools, no one is stopping you. That's basically there, just calling the APIs with whatever language you like. Just to get a basic idea of how much it's going to cost. Yeah, it requires maybe 30 minutes of your time, but once you have those tools, it's really easy when you get pings from teammates, managers, or FinOps team to give those answers. The reason I say teams, because in some cases when I work with different teams, I have backend team, I have front-end team, data team, they want to use certain things, let's say some CPU optimized instance, but they have no idea if it actually makes sense. So by me just running certain command on my laptop, I can say, yes, that's good. It matches what we can spend or not. It doesn't mean that I'm becoming the FinOps person who has like a bunch of Excel sheets, but I do help my teammates to just, design the apps faster. And then this is a tool I mentioned. This is a great tool. They do support, like if you, for example, using Google Cloud, you can have connector to the BigQuery, and you can all your billing with the Google Cloud you can collect in the BigQuery, obviously for processing. Their practices how you can do, and then since they don't have a good dashboard, you can just import that dashboard into the QuickSight. Let's say if you on Azure. With Azure, there is a storage called blob. So basically, once you build your building, you put in the blob, and then the blob has the billing and blob combination. Again, there's a manual what kind of data structure will be there, and there is on the top right. There is like this URL is public, so if you just want to see what you can get, you can use that URL, and then on the top right you can see different cloud providers, what kind of data you get, and it's pretty cool. It shows a lot of things. There are different dashboards. Just like imagining how much your team, company spends on those things are really useful, not just for understanding the bill, but understanding like what resources actually never used, what resources are over-provisioned or under-provisioned. And now I would like to review like a real example, to walk you through a real example in terms of like, where do you start? If you never, ever touched anything like that, and you just build an application, you may be great with Terraform, but you don't know how much you're spending. So my example is designing disaster recovery for company which operates during market hours. Let's say they do some basic trading. So the business importance to be up and running is during market hours, let's say in the United States, right? They don't need full-blown architecture, infrastructure during non-market hours. But there's still a lot of jobs that data team might use, or certain like Airflow. When I say data team, it's like Airflow, all the tooling they use to, let's do post-processing or pre-processing for the next day of the certain information to give proper data and things like that. My goal is to design quickly disaster recovery and calculate, or to give an idea how to start calculating that. So, and there is one term I'm going to use, which is cost factors. Not many people using it. It's not something like it's used. It's something that I use to understand when I have to start somewhere. And let's say you looking at your product, you're looking at this design. and everything seems important. But usually there are certain services that like second-tier services, some of them even third-tier services, and those are not crucial for the application to perform. Just to give an idea, in some cases, having the CI running up and running during disaster is probably not that important, as long as it's not responsible for actually automating or recovering from disaster, right? So if people during disaster or engineers cannot commit the code, it's probably not as bad as when product is just down and customers are mad. So that's when I say cost factors. It's something how we like define the level of the app in this architectural mesh of different services. So identifying the DR strategy, again, there's a lot of processes, there's a lot of documentation. I would recommend using those differently for different services. So if you, let's say, need RDS or, any database running nonstop every time, think about something like active-active when you have not a backup, not a snapshot, but full replication of that database in the region which is designed for disaster recovery. But if you just need a KS server, it might don't have to be all running in full speed. So for different services, we can decide different DR strategies, and that's okay. We can still calculate that and understand that. So for this example, it's Pilot Light. Pilot Light is the second one on this graph. And the last line in every column approximately guiding us through the amount of cost spent. This is, again, we can always optimize this or review, but that's an idea of where we would end up after using that or this strategy. So I decided on the Pilot Light, or I went to the company when they said, we would like to, or we already have Pilot Light, what are my steps? So as I said, I'm looking through all the services, I'm finding the critical workloads, I am understanding resources in terms of like what the cost factors are. I'm calculating my RPOs, RTOs, or I look through the compliance or DR strategies and finding those numbers. And then I create the disaster recovery process or work with someone who are part of that. Usually it's not one person, it's going to be a huge chunk of people around the company who understand different services. Utilization percentages are collecting the data, understanding this Kubernetes cluster consumed this many resources during this hour or every time. We have Airflow jobs, which runs nonstop. They do so many things that we cannot take it down. And we're analyzing the peaks, we're analyzing the usage, we're creating baselines, or we can just use the tool. As I said, most of the things can be easily already shown through the dashboards. And all we need to do is just enable them. So cost factors I covered, and this is a simple formula I use for myself to define that. Step 4. And then now the example. So my resources, after I did all the previous processes, and there is no need to follow the same logic, but it's just the easiest one. I just defined that we have some EC2 instances. If you're in a different cloud provider, there is some servers or whatever they instances. I have something which is seems like a huge cluster. It's not very used. It's used, but not very during non-market hours. And there are 2 other machines. Seems like they, in general, don't have a lot of load, but they do have memory spikes. So it seems like something is there. I have to pay attention. And there is a typo in the second column. It's supposed to be M5 24x large. And then I have an RDS database. It's decent size, and then C, it's constantly high. So probably not going to go through the optimization, because with my Pilot Light strategy, I already know that we probably will do certain replication steps, but I want to look through the backups of that database, understanding if there is snapshots, if there is a backup, how it's set up. And then there's SQS query, which have no impact on on bill whatever a lot. So even if they utilize 100%, we will not bother to optimize them at this point, at least. And then I look through through the dashboards, and I see, like on the previous slide, right on the last column, I mentioned that I see that I already see that it's high. 24 large instances are big ones, and I do work with instances and types. So if you don't see them, go back to the calculator, just find the instance, see the price. Very easy. You just Google it, and most likely you will get Vantage page, which is also a great tool. It's free, and they support Terraform if you use infrastructure as a code to get those costs. And basically, I saw that it's, and then I decided that I need to justify the instance for this recovery. This slide is very heavy and overwhelming, but the only thing I would like you to see is the monthly cost after using these instances are almost $9,000, sorry, $10,000. And then the failover, which is part of our pilot light disaster recovery, what it means is we fully spinning up the same instance type, but we just do that for 10 hours. 10 hours is, we think that the market only opens for 10 hours. So that's why we don't use them 24/7. So that tells me that approximately 42% of my spending monthly just goes into that DR solution, where a lot of things just standing and not actually doing anything. So then I will ask myself, is it a good solution? And again, I need to look through the compliance and understand if there is even a way to see why. Maybe something in that process that we cannot take it down anymore, but most likely that's not the case. So we would go back to the calculator, or there will be another solution, which I will show on a different example. But so far, we're just doing, again, we have the calculator, we're just selecting the instance type, which is maybe on the same family of instances, right? But then we are talking to the manager, and they're actually saying that we still need some instances running. They would be happy if we have them not just during market hours, but all day. But we definitely can probably scale down. So after scaling down, let's say we would get to the point where we would not run that many instances. We would go to one, and we would basically, for DR only, we would cut a lot of the instances with a different size. We don't need basically 24 X larges. The X large instances completely fit in the case for something that's there. Like, apologies, I'm gonna step to the other slide. So this pilot light, air, and warm stand-up, they require some things to be there, but they don't have to be fully loaded for our app to function. And with this condition, I can say that actually these 3 instances we can run the full every day, and this is how much cost we can cut by just doing that for that solution, right? Example number 2, we had RDS instance. It has this condition, like it has so many gigabytes. This is our backup storage, and then we realized that transactional logs cost this much. And we decided to just enable the continuous backup, which gave us the amazing option to recover everything up to 2 seconds, according to the documentation. And then we realized that it's only $50 per month for us to do that. So except having replication, we can always enable the backup, and it's really convenient. And, you know, we feel better if things go wrong. Or sometimes I talk to people who work with this kind of setups, and I say, hey, you always have a staging environment, and people take very interesting procedures and CI jobs to replicate data from prod to stage. But you actually can try recovering this backup on monthly basis, but you can do some cleanups and fulfill your staging database with this backup. In this way, you kind of testing your DR, which should be the process, and also helping engineers to get fresh database with good data. Don't forget to do cleanups and consult with engineering teams. So we see that the cost factor for this resource, I basically calculated it like that. And if the company spent $10,000 on DRs, having this much of impact is okay, right? $50 if we spend $10,000, totally fine. At least I can justify that. And in my experience, when I talk to leadership, it's important to provide that knowledge, just so they understand why. And there are other ways to, like, I can go deeper, right? I can review all the things we're backing up. I can come up with the requirement. Also, I just want to point it out that in some cases, having a backup doesn't save you from, like, backup is not your DR strategy. Backup is a part of the DR strategy that you're performing. So review it. Also, don't forget to have lifecycle policies. You definitely don't need backups taken 10 years ago. I don't think it will be helpful. So no need to pay for that extra storage, waste of the extra storage. But if you require to do that, not you, but your company by compliance, review the storages with Amazon, there is a Glacier, but all cloud providers have similar options. And like I said, there is a cross-region backup. Data transfer is something to consider. There is a multi-cloud backup, which is also very great. I know recently, I don't know if you heard the news, Australian government lost their backup because someone deleted it, but luckily they had stored similar backup on-prem or somewhere else, so they were able to recover it. So it's always a good solution, just you need to calculate how much it is, maybe compare all the cloud providers, don't pick one you know, and calculate if it's actually makes sense. Maybe you take backups often, but once a month's backup you can send to the different location. Again, it's, as I said, it keeps us thinking, it keeps us becoming better infrastructure engineers. Excuse me. When I started presenting first example, I said, there is option to use dashboards and don't do any calculation. It doesn't replace, to me, one tool doesn't replace the other, but it's also good to have a confirmation. So remember those servers where we had outside of EKS clusters, we saw there are some C5s were lying around. After talking to the team, we realized those are required for some data jobs or works or scripts, and they were not actually utilized fully. So with AWS solution, QuickSight, we can actually have this dashboard, this one called Cloud Intelligence, and it just reads whatever is already there. So it just goes through the different source of the information, and it actually shows us, like, you open this dashboard, you're curious about the compute, and you see that this C5 instance is actually not utilized well, and it's pretty much expensive type. And then on the same dashboard, when you just drill into the different view a little bit, takes time, but it's all in the documentation, you can find the recommendation. And I'm like, oh, that's great. Which one I would choose? Opening any page, I can do the comparison. On this slide, there are two recommendations. I hope you were able to see this is R and T. And then this recommendation seems like it requires 2 instances. I can replace, because my goal is to go with a more memory or similar memory efficient instance, I can replace 2 of them with 1. Will it make sense price-wise? Seems like it's a little bit cheaper, so maybe. Maybe not, because if you talk to the team, you might find out that this instance type supports by application. Or you see there is a bit of bandwidth difference. Maybe that's what needed for the team to work better. Or they actually never cared, and you can discover something else as well. Or let's say they say, hey, we don't need this even instance like we saw, it's not utilized fully. Maybe one T3 is great, or we can use the same instance type but start shutting it down. It's not hard. Every cloud provider has step function. Optimizing schedule step function takes not much, and this instance can be just taken down during non-useful hours. So after I did that, I would be approaching the person who gave me that task and saying, hey, we are on pilot light, but we can go a little bit upper into the better DAD strategy, which seems like a little bit costlier, but for our AKS clusters and instance of the database, we actually can think about a form standby procedure, which is a bit better for market hours. It will be better for our team. It provides some certain benefits, and cost-wise, it's completely fine. And then if, let's say, management still prefers pilot light, or the team sit down and the solution still go with pilot light, we get a lot of extra cost that we can define elsewhere. We can spend it on support, which is great. I personally learn sometimes a lot of good answers from support. So that's something to consider. And after I went through this exercise, this is how my new source code management with infrastructure as a code would look like. And I can present this, and if people want to see the numbers, it's also there. If we would use some kind of tool like that, we could estimate it. The reason I say fake it is because we would build that solution. We could build that solution, and we can tag it with infrastructure as a code, and then we can create a dashboard like this. They're all customizable. And after a day, because that billing data has to be shown, we will actually get the full dashboard with the tags. We would say tag equal DR or production DR application, whichever we prefer. And we could actually have the whole dashboard of the exercise we just did. It takes a little bit longer, and I don't think anyone who just started with that can set it up. But it is possible. And I think if this thing will ever be more picked up by open source people who are interested work in cost and finance, actually it could be a good start. And I guess at this point I will just say that a couple improvements not covered by this presentation, because it's on a case-per-case basis, and since we're not designing great disaster recovery strategy, whenever we build anything in the cloud, good thing to consider: schedule scaling. So whenever we have this, don't wait for spikes, but try to understand what will happen if, let's say, 20% of the traffic will all of a sudden be happening with the app you're building. Let's say the trading might happen, and then something hot happened on Reddit, and that caused the trading go up, right? Just think about scheduling your scaling in terms of not just never testing it, but also understand the workload patterns and how, what other things can cause those spikes. Another example can be, let's say, company working with brokers, and brokers usually have huge portfolio. When you're talking to the product managers, or sometimes you get this information that we're going to onboard this many people tomorrow, and those people will have huge portfolios. That's going to be a spike that we need to understand that we can even scale to that level. As I mentioned, tagging already, and then once you get more efficient, and if you actually have interest, there is a lot of things when you can reserve instances ahead of time, when you can have a huge discounts. Because if you work in a large enterprise, the last bullet point will definitely make sense, and then it's easier. You will even I hear the people saying, well, that handled by finance. But as an engineer, we still need to tell them what kind of instances we use, what kind of instances will make sense for us to reserve, right? Because we don't need instances, for example, which are mostly memory optimized. We want to have, it's good to have different flavors if the product allows that. And on-demand versus spot is a huge different topic. I think this is good enough for start. But Spot could be also interested. You don't have to pay for loads that actually not stale. But the reason I don't talk about it, because we're talking about DR, and DR, specifically during DR planning, you probably don't need to plan that deep into the reserving Spot instances. So that is one. And here's the summary. First of all, cost analysis is good. I hope I convince you that it's not only needed for financial and billing purposes, that actually it can make us better engineers to understanding. We build this great code, we package it, we put it even in this cool orchestration, and the Kubernetes or serverless, whatever architecture you chose, it's already doing certain things. But on the underneath, is it still efficient? If this whole setup makes sense, because if it costs a lot of money, probably it doesn't. And resource optimization, good to understand, good to review. So if there's something new on the market, it could be cheaper. You can get more efficiency with the scaling your cloud versus actually optimizing code for certain things. I know this is a bad statement, but sometimes it helps. And automation, all these things can be automated. Taking down resources, setting up autoscalers, it's all great with automation. So on this note, I appreciate your time and thank you for coming. That's it. Thank you so much.